This is example 1 for the COSMOSXpress lesson. Once you have the file saved to your own personal working directory, we can begin looking at the COSMOSXpress add-in. Now, the COSMOSXpress add-in is a stripped-down version of the COSMOSWorks add-in for SOLIDWORKS. With COSMOSXpress, we can only look at individual part files with a single solid body. Whereas with COSMOSWorks, you can begin looking at stress analysis for large assemblies. Again, COSMOSXpress is a free stripped-down version of COSMOSWorks. This free version allows us to analyze individual part files. To begin analyzing a file, select the Evaluate tab, and then select the COSMOSXpress Analyzation Wizard. The first step will welcome us to COSMOSXpress. Let's select Next. In this tab, we're asked to specify our material. Now you will note if you'd previously specified a material, COSMOSXpress understands that you've specified a material in the material area for the part properties. We can go ahead and leave this part being 6061 aluminum alloy and move on to the Restraints tab. A nice picture shows us the restraint is the portion of the model that's fixed. We'll select Next and label our restraint. Because we only have one restraint, I'm going to go ahead and use my default value. However, you could name this value to whatever you may choose. Next, we'll select the box that's asking us for the faces that are restrained. You can see that COSMOSXpress has automatically activated the Faces filter because the only entities you can select for restraints are faces. I'll select the face on the large boss, and we can see that we have a series of green arrows showing that that face is the fixed face. For the analyzation purposes, we're assuming that that face cannot move. I can now select Next, and had I wanted to, I could continue adding restraints. However, that's all I want for restraints, so I'll select Next. Now we're being asked for the loading area. I'll select Next. I'd like to apply a force, so I can select Next. And again, I'll select the face where the force is being applied, and select Next. We can see that I can load the face normal to the selected face or normal to a reference plane. So had I wanted the loading coming in on an angle, I could create a reference plane on an angle to force the loading to be coming in on an angle but applied to this face. And in later examples we'll look at how to do that. Now we need to specify the value for the load. We can either use newtons or pounds. I'll select pounds, and I'm going to apply 50 pounds to that face. Had I wanted to, I could flip the direction of the loading, but the loading was in the correct direction, so I can select Next. Again, we're being asked if we'd like to add loads to more faces. And again, in this case, this is the only face we want to load, so we can select Next. It's now time for SOLIDWORKS to run the analysis. We'll select Next, and then select Run. By the graphics we're seeing, we can see that SOLIDWORKS is creating a mesh of the geometry to run the analysis on. That analysis was rather quick, and it says the analysis is complete, and based on our specified parameters, the lowest factor of safety in our design is .974. So, a factor of safety below 1 means that the analysis suspects the part will break at that point. We can go ahead and select Show Me. And it's a blue is good, red is bad scenario. We can see that the problem lies in this corner in here. So we'd like to go ahead and update that model to fix that corner. If we select Next, we're asked if we'd like to optimize our design. However, in this case, I will skip this process because the next example is going to get into optimizing a design. Let's just go ahead and select Next. And now we have a series of options for how we want to show this model. We can select to show the stress distribution in the model. We'll start by doing that and selecting Next. We can see that we have a graphical representation of the stress. Noting that this model is exaggerated, so you can't use the distance graphically that this part has been displaced to determine how far the part has been displaced. It's simply showing graphically the most affected areas. So again, blue is the best, red is the worst. We can see that our yield is where the arrow is, so anywhere above the red, the part is yielding. So again, in this area, in these fillets, COSMOSXpress is expecting our part to yield. Again, the same thing on both sides. Now, of course, something that users often love to watch is to press the play button and animate the stress distribution. I know it's interesting, almost as interesting as Google Earth, but don't waste your workday watching it. I'll stop the animation and select Next. I could now go ahead and show some of the other statistics for this analyzation. Let's look at the deformation of the model. Again, there's no colors in this. It's simply showing in an exaggerated state how the model deforms with our specified loading. Again, we can watch a fancy animation. Now, the last important thing is to generate an HTML report. If we select Generate HTML Report, we can select Next. In our report, we'd like to include a cover page, an introduction, and a conclusion. And then we can select Next. In this particular case, my title is going to be Inspirtech Lesson 18 Example 1. The author is Al Whatmo. That's my name. And the company is Inspirtech. If you'd like, you can select a logo, and then you can enter the date. We'll then select Next. We can now add an introduction to our page. I'm going to say this is an example. And we'll select Next. The conclusion. For our conclusion, we found that the factor of safety is too low. Modifications need to be made. With that complete, we can select Next. We're now being asked to save our file as an HTML, and we can select Next. SOLIDWORKS is currently creating screen captures. And now we have an HTML file including all the data for our stress analysis. The parts described, the materials described, the loading and restraints are described, the mesh information, which is the information that was used to turn the solid body into a mesh that the computer could analyze. And now the results. For each result, there's an image. Well, this is a great tool for documentation purposes when creating parts that are required to meet specific stress-related design constraints. Well, I hope this example was a help, and we can now move on to learning how to optimize a design using COSMOSXpress. Thank you, and have a good day.